Thank you so much for waiting. It's definitely worthwhile waiting for, because today we are doing the prize ceremony for the Edge Annotations Challenge. We have been waiting for this moment for quite some time now, since planning for months, doing the challenge for a couple of weeks, seeing the teams sweat and really taking on this challenge in a great way. It's been a great ambiance and super nice spirit within the teams. We've had a Slack channel and daily meetings with them to see how everything is going, what they're working on at the moment, etc. And when I say we, it's us, AI Sweden. My name is Ebba Josefsson Lindqvist. I'm project manager for the Data Factory here at AI Sweden, and we have collaborated on this challenge with Sensac. First and foremost, the data set and the challenge comes from them. It's been part of the Road Data Lab that you will hear a little bit more about just in a few seconds, where we have RISE as partner. We also have Universes and Lund University. We are collaborating with Mobility X Lab, and CGIT has been a very strong supporter, helping out with the infrastructure during this challenge. So it's been really, really great. I'm really happy to kick off this prize ceremony event today. And first of all, I want to welcome Thomas Olsson from RISE, the project leader for the Road Data Lab. Thomas, how are you?
I'm fine, thanks, Ebba.
Great. Thank you so much for being here, Thomas. So this is kind of a little bit of at the end of the Road Data Lab project term, and we're finishing off with something fantastic like this. So how are you feeling?
Yeah, I think it's been really good. I mean, the Road Data Lab project is about establishing an open data ecosystem and really supporting open innovation. And I'm happy that we were able to do this challenge to prove at least that it's feasible to do this type of activities. And I'm really glad that we will be able to publish the data then as well through AI Sweden after the challenge.
Yeah, I think that's fantastic, and we will hear more about that in a bit from Benny and Mina. But so with the challenge, what was the most fun part of the challenge for you?
I think it was interesting that the teams came up with such a different solutions, and really this proves, I guess, the whole open innovation part of sharing a data set that's can be used by different actors in the innovation ecosystem. So I think that was really interesting.
Great, thank you so much. It's been great working with you. We really look forward to seeing what will continue to come out of the Road Data Lab. And this is kind of just the beginning of how the real community when it starts. So wonderful. Thank you so much, Thomas. And I would like to welcome up Benny and Mina from Sensac. So please take the stage. And you guys will have to share the mic. And don't be shy, come a little bit over. Oh, that's actually perfect where you stand right now. So Benny, who are you at Sensac? We need to know that.
I am the head of emerging technologies, and that means I do a lot of both internal projects, evaluating new interesting ideas, but also a lot of work with startups.
Sounds pretty cool. And Mina, what's your
role?
And
I'm Mina Alipegi. I work with technology and collaboration, do some research and also podcast studying, helping with Benny. Yep.
And so here we are today at the prize ceremony, but it didn't start here. It started long ago. Why did you want to do a challenge?
Yeah, so let's start with the name of the challenge, Edge Annotations Challenge, and what do we actually mean with that? So I want to start with highlighting that the focus of the challenge has been around doing automatic annotations at the edge, and that's important. And for Sensac, the edge means vehicles. So we wanted to do automatic annotations within the vehicles. And then the question is, why do we want to do that? And it has to do with when we first release our autonomous drive software soon in the future. We will have something called operational design domain that will be very limited initially. And that means that we will only be able to do automatic driving, for example, when we have divided roads, good weather, daylight, and so on. And then the idea is that we slowly expand this operational design domain with the help of over-the-air updates over time. But to do that safely, we need more data to both train our algorithms and test them. And some or quite a lot of this data is very rare. It's difficult to find. So if we want to find that data with our development fleet only, that is both very inefficient and takes a lot of time. So then we have the opportunity instead to use what we call the customer fleet. This is the fleet of vehicles containing our software that we have sold. And this fleet is many order of magnitudes larger than our development fleet. So by using that, we could be much faster. But because of that, we have new challenges, especially with privacy laws. You have probably heard about GDPR. And because of that, it's very difficult to move the data that is being produced in those vehicles away from them. And this is then where something called Federated Learning comes into play, which is a potential solution to that. And it enables us to, it's a tool set to enable us to improve our models within the vehicles without having to move it. And that way we are compliant with these privacy laws. But then, of course, new challenges arises. How do we actually improve and update these models within the vehicles with having access to manual annotations, which is the normal way of doing it with supervised learning? And this is where this hackathon comes in, where we want to explore the potential of, or we have explored rather right now, the potential of doing this automatically within the vehicles instead. So this has been the reason why we have done this.
I think that's pretty exciting, and also to later on hear some of the takes on how to tackle the challenge and how this could potentially work. So let's see, but that's a bit later. Mina, the data set for this, it's really been your work.
Yeah, it was a contribution from many people actually,
That's
but
true.
yeah. So yeah, basically, as Benny said, the idea and the motivation behind the challenge. And so we ended up defining this problem as how we can generate high quality annotation in an automatic way, such that we can train a single 3D, single frame 3D object detection model in a supervised manner when we do edge learning in vehicles. And what we did during this challenge, actually, the solution that teams comes up with, we try to measure that with an objective metric. So we kind of it's kind of clear who is the winner from the objective function. And then, it was very interesting. It was a tight competition between the first two teams, but also all the teams had very interesting solutions, and they approached the problem from different perspectives, which was really great, and we will hear about it soon. And then, in this challenge, basically, we use the Sensac dataset. We call it Sensac Open Dataset, and it's basically a brand new multimodal and sequential dataset. It contains comprehensive annotations for different tasks, and it's from both day and night and during different weather conditions. And basically, this dataset was open to participants in the challenge first, but now we are opening that to everyone. So basically, you will get a link in the chat where you can find it, but you can go and download it and use it as freely as you want. It's a very permissive license as well with the dataset. And we are also opening the development kit that is provided with the dataset as well. And in addition to that, we saw that some teams were very eager and they had more ideas that they wanted to try out. So we are also providing challenge data. So please continue with your solutions and even try out new ideas and let us know how it works. So yeah, we look forward to that, because all these solutions basically shows that this challenge is kind of feasible to do, which can enable what Benny said, which is about like breaking actually having a breakthrough for improving and developing autonomous cars. So with data coming from the customer fleet, which would be really exciting. So yeah, look forward that you continue with
your
that.
goal is reached, kind of,
yeah.
in a way, or at least the start of it.
Yeah, exactly. Yeah.
I think that that's really wonderful. We will hear a little bit more from you guys just in a short while, but before that, we'll also hear some other voices about a challenge like this. But thank you so much. And just as Mina mentioned, there is now in the chat how to get access to the dataset directly from Sensac.
Yes.
And then we will also still have it available here at the AA Sweden, for example. So there is a playground out there now.
Yeah. Yeah.
So thank you so much for now.
Thank you.
You can just leave the mic there. Thanks for that. And we will have some quick input from Jonathan from Universes and Simon Jonek.
Hi, Ebba.
Hi, Jonathan. I'll just wait for Simon to come and join me here as well on stage. But Jonathan, please go ahead first. You're the CEO of Universes, one of the project partners for the Road Data Lab.
That's right, absolutely. So we've been a huge privilege to be part of this Road Data Lab project. I think it's trying to do a fantastic thing. We are a relatively small organization with Sweden, about 50 people. And so we recognize the true value of sharing data. We can't do it all by ourselves. So it's been really, really great thing to be part of. And also, of course, this great hackathon. I'm really excited to see the results. We've actually had two of our great engineers, Ernesto and Johan, acting as judges and contributing in many different ways. So super thanks to those guys for all of your work, and Joanna as well. And just really excited to see the results. Many thanks for the involvement. Really good news.
Great, thank you so much. And thanks for highlighting your teammates there, because they've also put in a tremendous work for this challenge. And same for Simon from CGIT.
Yes.
CGIT is helping out with the infrastructure for this project.
Sure. Yes.
And you have put in a few hours, Simon, on this.
There's been some challenges, but we overcome most of them. So we've been providing the support for the technical platform and all the access for the participants, and also participating during the daily meetings and stuff like this. So it's been great to see that all the participants have been such a friendly bunch. They help each other even though it's a challenge. There's been an open climate, and there's been support for everyone. So I'm super happy to see that everyone is so open, and it's also inspiring to see these great minds come together and bridge challenges that we all face for the somewhat greater good. So it's great to see. And of course, we at CGIT, the entire team has been behind me as well. So it's not just me. So we're all happy to see that we've been successful here, that we have a great challenge and good results.
Yeah, and from all of my heart, thank you so much, both of you and your teams, for really contributing to making this challenge so well. So thanks so much.
Thank you.
Pleasure.
Thank you so much, Jonathan.
Bye-bye.
And to actually broaden the perspective just a bit more, we've asked some people who were not involved in the challenge itself, but will help us to take this challenge and what the teams have tried to solve here and actually bring it up to orbit. So we have two wonderful speakers with us, Pierre-Philippe Mathieu from ESA, the European Space Agency. And then we also have James Parr from the Frontier Development Lab. Welcome. Hi.
Hello.
Everybody.
Hi, how are you? Let's see if we have James with us as well.
Yeah, I'm here.
Yeah, Felipe is here, and let's see if we can see also James. There you are. Okay, great. So Now, you heard a little bit about what the challenge here was. This is set in a road data setting. You guys are working kind of outside of Earth, circling around, perhaps. Would you just first want to say, maybe James, the Frontier Development Lab, what is that?
Well, actually, we do a lot of work on Earth. I mean, all our work with Pierre-Philippe and the Phi Lab is about Earth systems, using machine learning for Earth systems, climate, disaster response, and those sorts of things. So yeah, we're very terrestrial in our focus, and but yes, we produce machine learning pipelines for big problems, things like understanding the interactions of aerosols and clouds and real-time flooding from orbit, those sorts of things.
Wonderful, thank you so much. And Pierre-Philippe, you're at ESA. Would you just want to describe a little bit on what are you doing on a daily basis?
Oh, it's a big question, Eva. So thanks for your invitation. So at ESA, we are basically trying to build an observing system of the planet, a kind of microscope to understand what we are doing as a species, to understand it for the knowledge of the Earth system, so advance our understanding of ocean, land, ice, and their interaction as a system, but also to create new applications, new services based on this data. I have the privilege to work in a field where the data can be used both for science and application like this. So it's really relevant for society and for the economy. And what we are trying to do is to explore new technologies, digital ones like AI, to see how we can mine this big data. And we do this on Earth, but once we have the software, we can upload it in space and then augment our sensing system with this capability. So that's why we are really close to what you have just discussed in this challenge.
And that's why what I really want you guys to elaborate a little bit on from your different perspectives here. So we haven't heard about the actual solutions yet, but we've heard that they might be on track to actually solving it. What would it mean from your perspective if we could actually solve this with the automatic annotations generation and having much more help with that instead of manually always doing it?
I'm happy to jump in first, Pierre-Philippe, if you'd like.
Go ahead.
I mean, I think it's incredibly exciting, and I'm sort of kicking myself that we didn't think of it. So congratulations. I think it's a really exciting problem, and I agree with the speakers before, like there's some interesting interfacing with federated learning, but fortunately these two things are maturing quickly, and I think the combination of federated and the set of tools for out of distribution problems unlocks so much. And I'm going to go sort of, well, we have a clear and present problem which we could use this for. We have a machine learning software that's running on a drone looking for sharks on Australian beaches. And of course it works beautifully on those beaches where the drone's been trained on, but how do we make this work in beaches around the world? And it's the sort of potential for open science to meet with citizen operators, so we can start building these knowledge graphs that people can sort of use in an interoperable way. This is the potential, and I think I've seen this, been watching the NLP community do this very well. They create these open knowledge graphs for the benefit of all, and I think having these sorts of tools for like the visual learning community would be really powerful. And it unlocks all sorts of things. I mean, if Elon Musk wants to do his robot, he's going to need to have this sort of mechanism in place. And I think probably in reality, if we want to have, cars that aren't just working in Silicon Valley, but actually work in countries around the world, that this is the pathway to get there.
Yeah, that's great. Where we have snow and ice on the
Exactly,
roads,
yeah.
perhaps, right? Like
Yeah.
here. And Pierre-Philippe, what do you say?
Yes, I think that the challenges you have, for example, in automotive is something, in fact, very similar to what we will find in space, or we are currently finding. It's, for example, we are delivering petabytes of data on the state of the planet, but we have very little annotated data. So there are efforts now, and we are running some at the Lab with a gaming engine where we ask the gamers to annotate data to cross-check between them if the annotation is robust, because there is this other issue of uncertainty of the annotation. But what we are ultimately after is a hybrid chain whereby you would combine some supervised learning, some unsupervised learning, and maybe some reinforcement learning. In fact, any type of learning, even the federated one. So I think we have a lot to learn talking about learning from your community. And the beauty is that it can transfer very easily to our community, because this is the same problematic. And I'm really impressed by the self-driving car industry, which is putting in place, let's say, this engine to look at the world in different frequencies, which is what we do, from different perspective and angle, which is what we do, to build a synthetic version of the world, which is what we call a digital twin of the planet, in order for the car to drive with a knowledge framework in this. And when they don't have data on extreme cases, they just generate it by simulation. And this is also something we are after with synthetic data. So this challenge, I think I would dream to do it for space, because I think your community can in fact disrupt us.
I was going to add to that, that it's really interesting, this idea of using, if you like, communities to build out a sort of collective label or annotation or knowledge graph, or whatever we decide to call it. And there's one thing to do a description of the object, but then there's another job to do, which I think communities are very good at, which is the intangible layer of labels that human beings tend to associate around objects. So baby versus Charlie versus Simon, which is well known. But I could see a future where we start to create like a layer of meaning as well on top of these labels to help AIs make better decisions. Of course, there are a whole lot of ethical implications there as well, but certainly it feels like it's a very exciting area.
Great, thank you so much. And I think also, Pierre-Philippe, you mentioned something else there with using gamers. I think there are a few different communities that we could maybe bring together for the next challenge. I mean, this problem is not solved, we just have some potential solutions, right? So it would be very interesting to see how we can use, for example, the Edge Learning Lab that we have here at AI Sweden, and merge all these competencies from space, from automotive, from maybe some other potential areas, bring in some gamers and maybe some VR glasses, and I think we have a really fun challenge coming up pretty soon. So Pierre-Philippe and James, thank you so much for broadening our perspectives on how important it actually is to solve these questions together. So I look forward to seeing you further on.
My pleasure.
Thank you so much.
Thanks for the
Thanks for inviting us. Yeah.
Wonderful. Great, and now we come into the really, really fun part. We're going to hear the teams present their solutions. And we have a list of in what order they will present, and you can see it here. And we have had 5 teams, and you will obviously then meet them now. So FCC Fraunhofer, Annotel, Backseat Drivers, which is from Semcon, Combitech, and Galaxial. And they've all done a really, really good job. So we can't wait anymore. Emil from FCC, please go ahead and share your screen. We'll stop sharing.
Yeah, sure.
Welcome. Hi.
Then let's hope this works.
It seems to work, and you are going into
Does that work?
Yes, we can hear you, and it looks great. So
Perfect. Okay.
You have 5 minutes, and then we'll follow up with 2 minutes of questions. So now when you listen in, please feel free to ask some questions, either if you type them in the chat or ask them, you have to go, of course, in the chat as attendees. So please ask your questions in the chat, and we may have something from the panel here. So Emil, please go ahead.
Yeah, so thank you. So my name is Emil Gustafsson. I'm the leader of the team FCC. So FCC, for those of you who don't know, it stands for Fraunhofer Chalmers Center. So we are a research institute that performs research and applied projects in applied mathematics, machine learning, and AI. And the team from FCC that was involved in this challenge is me, Emil Gustafsson, Henrik Håkansson, Mats Sierstrand, Anders Sjöberg, and Magnus Unnheim. So thanks to my team. It was a really fun challenge. So let's dive right into the kind of details in some way. So our solution can be viewed as some kind of a pipeline where that goes from the left to the right, where on the left you have as input what is provided in the challenge. So basically the LiDAR data, the camera data, and the odometry data. That is what we do. So it starts to the far left, where we start by looking at LiDAR data, so all the LiDAR frames that are provided. We feed those to this point pillars model that was provided in the challenge. And after that, then we're left with a sequence of frames where each frame then is consisting of a number of detections, basically, a number of LiDAR detections. And the next step after that is the tracking and smoothing step. And here I'll go into some details at least. So basically the idea here is that we have a sequence of detections and we need to match them together in some way. So we do this by solving this, it's called a data association problem, as a mean cost network flow problem. We solve it as a network problem with some interesting weights on the edges, you can say. Once that is done, we have made our tracking basically, so we know how our detections are matched to each other. After that, we perform smoothing, and the smoothing we do is by a linear column. So that is the tracking and smoothing step. The next step, we go further in the pipeline. We basically now have a set of LiDAR detections. And what we do then is that we feed those into this Detectron 2 model. So this model that can look at the camera images. And we say that, okay, at the regions in the camera world where we have seen LiDAR detections, the Detectron 2 model should probably look there, because probably there should exist some detections. We kind of feed proposed regions from the LiDAR detections to this Detectron 2 model. Once we've done that, we're left with camera detections and LiDAR detections. So the next step is to try and match and merge these together in some way. So we do this by solving another type of optimization problem, which is called the matching problem, where basically we use the intersection over union measure between the detections in the camera world or the camera coordinates. And then we match those and we merge the information that we had from both the LiDAR and the camera detections if we had a match. And then we go to the final step of the pipeline, which is the step we call the post-processing step. And here, basically, we have done a lot of things in the pipeline and gathered information throughout the pipeline. So we have information about the point pillars model, what it said about the detection. We have information from the Detectron 2 model. We have information from the tracking and also the matching and merging. We have a lot of information in the post-processing step. And here it's a matter of using all that information to maybe tweak the detections in some way, or maybe removing or adding or something like that. And then after this step, we are left with the final pseudo annotations that are the output of the pipeline. So that is kind of, as you know, the ones that have been involved in the challenge, there are tweaks and tricks everywhere here, but it's basically how the pipeline is. And with that, I would like to say thank you for a very interesting and fun challenge. And it's going to be interesting to see the results. Yeah.
Great, thank you so much, Emil. And as you mentioned, you have a few teammates there, right? You guys based in Gothenburg?
Yeah, so we sit in Göteborg. We're a research institute here. We sit in the Chalmers area, so in the Chalmers Teknikpark. So we're around 70 people in the research institute, and in our department, we're around 20 people working in machine learning and AI.
That's great. Thank you so much. And we'll see. So we do have a question here. How much do you think proposal regions helped improve the 2D detections?
Hard to say. It helped somewhat, I would say. it helped with the detector 2 finding some detections that it wouldn't have found before. The problem was maybe that kind of the way the detector 2 found those proposed regions without our help was fairly good as well. So the results were maybe not dramatically better, but it still helped, I would say.
All right, thank you so much. Wonderful. So for now, I can't see any other questions, but you had some contact information. I'm sure we can get a hold of you if there are some follow-up questions or interest in knowing more about the solution. So thank you for that, and you can always find them through AI Sweden. We will also, of course, post some more information on the AI Sweden website, so you can see more about these different solutions. But thank you, Emil. That's great.
Yeah, perfect.
And I will now welcome Team Annotel, and Roland. Let's see if we have Roland on the call. I actually might not have seen him, so we might pop on to the next speaker, actually. We'll save Annotel for a little bit, and then we go to backseat drivers, because I know Axel is on the line.
Yeah, hi, thank you, Ebba.
Hi.
See if I can get my screen shared here.
Yes.
Go.
I think you have to tell us a little bit about the name also.
Yeah, well, the name kind of just, we were just in one of our planning meetings, we were just having a good time thinking, you know, how can we make a little, think of something a little funny to I don't know, to set the tone. So because this was always we worked together, 5 of us, never specifically together in a project. So we wanted this to be first and foremost something fun to do together, maybe cross some competence areas and learn from each other. So we started with the fun and then grew from there. That was the idea.
Cool. Okay,
so
great.
yeah.
Thanks. Go ahead with the presentation.
Yeah, you can see my screen, right?
Yep, it looks great.
Great. Okay, so as before, we 5 members of the team. Myself and the rest of the gang. 2 of us have more focus, Saurabh and myself, more machine learning focus, and then Johan, Andreas, and Golam more in integrated or embedded software design and analysis and data-driven sort of work. But all of us sort of combined our efforts and had fun with the challenge as well. So in the beginning, we thought of 2 separate approaches, kind of with 2 scenarios. One, if we have high fault or high number of missed predictions, if you will, and that was the first idea, where we thought we might have to provide our own predictions to sort of give options for whatever selector system that we could come up with to choose from, and then also just to pad the existing predictions. So it's typically better to have more to choose from and then be able to cut down when the goal for us was to reduce the false positives rather than I mean, as well as increasing the true positives, of course. But we figured that would be a good approach if we had many missed predictions. And then the second one was if the number of predictions were quite good, but the issue were to tune them so that they fit better the actual object that they're predicting and or classifying. So then the focus was more on maybe generating something like an ontology and applying semantic reasoning and be able to figure out whether or not a predicted object realistically could be what is being predicted and so on. So those were the first 2 approaches. We spent a bit of the first week trying to refine those things. And then we realized since we were confined to some times in the weekends and some after work time that we were kind of running out of time, and we'd been a bit optimistic maybe with our solutions. So we narrowed our scope and we wanted to focus on providing some extra predictions using some Kitty benchmark models that have proven well in their chosen categories. We wanted to isolate the problem into separate classes. So we use this 1v-all and slow the predictions down and try to focus on getting accurate predictions instead than the fast networks that I think are more in play when the car is driving and having to make split-second decisions. And then we wanted to follow that up with filtering of that both inputs and then tracking and selection ultimately on the predictions in the end. But then that even proved to be a bit too much time-wise, so we ended up not being able to get our own predictions up and running, both from technical reasons setting up those models, and then also the training time that it takes to train the model from with all that data that is provided. It just proved too much. So we ended up doing the filtering, tracking, and selection part on the predictions that you provided essentially. But similarly to some of these models that were mentioned before, we wanted to have a all-in-one model here as an example that does scene sort of proposals, region proposals, and then moves on to predict in sort of an image classifier, and then that goes on to predict in three-dimensional space. So we would get both 3D and 2D bounding boxes out of the same model, but split over the three classes so they would be focused. But besides that, we also wanted to change the perspective of the LiDAR data and change the framework or the perspective into the eco vehicles perspective and reason to do that to improve the tracking that we were attempting. So there would be less the objects flying towards the car and more that the car and everything around it would be matched to the speed of the vehicle. And then also things that are stationary would remain stationary, ideally, in the LiDAR data especially. And there's some results, difficult to analyze whether these were helpful because we didn't manage to feed these into the tracking algorithms that we ended up using, but this was the general idea to move the perspective into the so the vehicle is the center frame, and the world is sort of in the right perspective, so to say. We did manage to do some rudimentary tracking, mainly just doing distance measures between the detections from frame by frame, and then once you have a cost matrix, you can sort of optimize that problem to find the matches between each frames. And we did this for two-dimensional and three-dimensional objects alike, which, some of the outputs here is a little bit difficult to transfer over what is happening here, but we tried to track the objects between frames to some success. And then the last bit of actually combining these two 3D and two-dimensional predictions, as well as mentioned before, we sort of projected the edges of the bounding boxes into two-dimensional space, and then the intersection of union as well to try to get these things to select matches basically between these three-dimensional and two-dimensional bounding boxes. So yeah, I think I'm not sure where my time is at, but that's pretty much it for us.
6 minutes, so
yeah. All right, good
timing to stop. Thank you so much. And I'm having a quick look at the chat to see if we have one quick question here. Which models did you use in the Ensemble, and any reflections on the requirements on those models to improve performance?
Yeah, so we attempted the first point nets due to the architecture looked quite promising, and the scores that it had achieved in the specific classes were quite good, but that model turned out to be really difficult to set up due to it being 4 years old, and a lot of the dependencies were, it was difficult to set all the dependencies up, so that ended up going nowhere. And then the OpenPC DET, I guess, framework, which supports a lot of these models, we attempted as well to set up. That was simpler, but ended up having maybe 2 days to try to train it and put it into place. So that wasn't fruitful either. But those were basically, the idea was to select models that had proven to be good in their individual classes and then try to combine that together.
Thank you, great. And we know it was a time constraints because we set it up that way.
Yeah.
So good work on that. Thank you so much for the presentation. We'll head on to the next team. And Roland from Annotel, I know you're there. We have.
This time I am.
This time you are. I know you were in the meeting. We just had you in the wrong group. Please. Share your presentation.
Try to see if this all works. Does this look good? let me actually go back to the start of the
Start from the
presentation.
beginning.
Conclusion.
Exactly. That was quick. And questions? No.
Yeah, indeed. Let's start with the questions and then I'll do the presentation.
Exactly. So
Cool.
here we go. It looks great. Go ahead.
Yeah, so anyways, we have Team Annotel consisting of me, Roland. We've got Clément, who's sitting there on site, Jonathan, and Luca. And what we try to do is take a human-inspired approach to auto-annotations. So we are a data labeling company, and we have a data labeling tool. And we looked a bit at what does our tool do well and what do our annotators normally do. And we have the following 4 observations, which we base our solution on. The first observation was that objects which are close to us with a large number of points are normally easily visible in LiDAR data. But observation 2, for objects far away, annotators guide themselves using the images. And observation 3, when they do this, they change their view on the image a bit by zooming, changing the intensity of the image to find objects better. And that brings us to the last observation. It is easier to identify objects in our keyframe if we see the sequence before and after the keyframe. So I'm going to quickly go through these 4 observations. As I said, the first thing was that objects with a large number of points are easily visible and recognizable. Now is a great moment for videos to not load, but well, because we have no videos. So anyways, so what you can see is that these cars, if you know what to look for in point clouds, they are quite clear, quite visible. That's because they have a large number of points hitting them. So for these, we can run the default provided point pillar model on a large region of interest to also capture objects which are farther away. Let me try to go to the next one. Yeah, so what we also tried is create denser point clouds by aggregating multiple clouds over time, but we didn't really have enough time to train and test the detector on this. But this is something which we hoped would have helped us in the end. But yeah, if we look at the annotators guiding themselves using images, normally our annotation tool contains a so-called pizza slice tool, which allows annotators to give a color to points in a certain area of an image. So basically, if you have a bounding box here, we color all the points in our tool like this. So that includes things which are maybe before the camera and the big pillar here behind the cyclist. So what we did is we used the predicted 2D bounding boxes to also give a color to the point cloud by replacing the intensity of the points. So the more vulnerable a road user was, the brighter the points would be in the point cloud. So we projected that onto our point cloud and then trained the model based on that. So that looks kind of like this, where you can see that the cyclist here gets a specific color, the pedestrians here get a specific color. You can see a lot of bleeding out, but objects which are actually pretty far away, they are still easily recognizable, which before they were not. Yeah, then the third thing we looked at was changing the view on the image. So annotators tend to zoom around, scroll around. So we tried to improve our 2D detections by merging detections on separate augmented images. So basically you take the main image and then you change the brightness maybe a bit, or you do a horizontal flip, which means that the traffic light is now on the other side. And then we all throw through the same model and then merge the predictions by averaging them in a specific way. And we also tried to use multiple models to try to account for weaknesses in individual models. But unfortunately, on our personal test set, it didn't really lead to improvements, as the detector we trained was already quite good. So that was a good bonus, but also something which we spent a lot of time on, which didn't really work. Whoa. Now things are really acting up for me. Okay, so that brings me to the last point. It's easy to identify objects if you look at the past. So what we try to do is get the predictions for different frames and then use multi-object tracking using this specific library. That way we can recover tracklets, and then we just did linear sum assignments to associate the 2D and the 3D objects. Let's try to see if videos want to play right now. it looks like it still only shows the initial frames and then stops. Here you can see some of our predicted bounding boxes. So you can see a pedestrian, the cars are really well detected, but things which are behind other objects are still harder to do. It's really interesting that yesterday the videos did work, but today not anymore. Let's see if this one works. Yeah, okay, also only the first few seconds. But yeah, here you can see the same. We believe that our detections are relatively good. There's some low quality, like low confidence detections in the back as well. I can maybe talk about that later. That brings us to a conclusion. So basically, we believe that our approach to high quality human annotated objects also improved our automatically generated annotations. We believe that objects which were already easy to detect, like cars, give a reasonable result when being automatically annotated, but objects which are harder to annotate, like bikes and pedestrians, are also harder to auto and pre-annotate. So I believe that maybe having more data, spending more time on this problem would help, but there's still a need for high quality manual annotations in the future for this. And last but not least, so we believe that we scored maybe half a point higher by including a lot of uncertain boxes. And in the future, there probably needs to be a bit of a better metric for annotation quality if we want to justify using a dataset like this. Yeah, that's the end. I can try one last time to get this video working in the background, but nope. Looks like we're ready for questions.
Yep, I'll shoot a question and we'll see if the video comes along. Can you elaborate briefly on the logic behind the 2D, 3D association?
Yeah, so the thing we try to do is, so for the association, so first of all, for the score, actually it doesn't matter in what way you associate them. It's not a penalty, but what we did was project all the 3D boxes into 2D space and then just look at the maximum overlap. So that way we find the closest match between those objects. What we did is we just tried to associate all the boxes, but then give a low confidence for, like we just took both confidence and divided them by 2. So objects which are either not clear in one frame, like in camera or in LiDAR, they get a really low score. You can also see them still being included here, but with a very low confidence on our side. So we do get a bit of the points if they are actually correct, and we don't lose that much points if they are not correct.
Great, thank you so much. And just one super quick, what did you think would be a good metric for evaluation? For evaluating the quality of the generated annotations?
Yeah, so to be honest, we are still looking at this a lot at Annotationz. So we would like to eventually have a bit of a better metric for annotations overall, because some annotation mistakes are better or worse than others. Like for example, there is a low confidence annotation here in the bottom. I like if there's not a car, it's not that bad if we actually predict it, because it is something you have to think about. But sometimes we also have missed detections. Like imagine if there was a pedestrian here, that would be really important to spot those. So I think it would also be interesting to maybe include the severity of the annotation error into some score. And think a bit about, okay, which objects are really important and give them a higher score in the final score.
Thank you so much, Roland. Great, and maybe we can help in some way to see if we can share these videos afterwards on AI Sweden's website, for example. So thank you so much for the presentation. We'll hop on to the next.
Yes, I believe that.
Hi, is it Marcus? Yes.
Yes.
Marcus Gudstrand from Combitech.
Yes. Let's see if I can share myself. Hello, and see if we can share my screen. Share. So you can see the screen?
Yes, looks great.
Yes. So yeah, as you said, my name is Marcus. I represent my team from Combitech. This is our lovely core team members, Jonas, Federica, Anton, and Emily. So let's see if I can switch. No, there we go. So just some background to our thought process. So we wanted to try to make use of the already made 2D and 3D detections that are already supplied. The problem then being that there is no association between the two. We aim to, so then our solution aims to create this association, of course. But to make use of more of the raw data, we also aim to improve the 3D detections with the use of the temporal information from the raw data. So some obvious pros with this is that we don't need to train or retrain our own detection model. But the cons are then it's harder to associate or create associations post-detection. So our solution is twofold. So we want to first improve the 3D detections based on the temporal dimension. This is done by clustering. And then we also needed to associate the 2D and 3D detections. So there are like two problems that we solved. The 3D improvements made through clustering. So this keeps information about that is already made about the class. So yeah, what kind of class it is, etc. And then the association problem is solved through sensor fusion between the 2D and 3D. So the clustering, we used a clustering method called dbScan to cluster objects based on X, Y, Z coordinates and time. And we did cluster, we clustered in rounds, you could say. So first we took out stationary objects because those are obviously easier because they are stationary. So this improved, of course, the positioning of the 3D detection. Then we clustered moving objects, and the problem we faced was if you have two cars driving in parallel, the clustering will see that as being of the same object, which it's not. So we do this. So we cluster a second time just to see that we only have like 21 LiDAR point clouds, or for a single object, you could say. So if a single cluster has more than 21, it's obvious. It's obviously not just one object. It's probably two. So this somewhat improved the clustering for moving objects. And the sensor fusion, we tried to project the 3D center points onto the 2D image, and then see what. Then we looked at the 2D and 3D center points that were closer to each other and tried to pair them that way, creating the association or link between the 2D and 3D, and then the 3D through time. And then the 3D bounding box or center point is then improved by the previous clustering step. So yeah, that is very brief what we did, and I want to, of course, thank all the Comtech team members. And yeah, that's about it for us. I hope I made it in time.
Yes, you did. No problems at all. And I have one question here for you. Yeah. Yep. So the question is, you used two clustering rounds, static objects and moving objects. Why do you think it was essential to have separate clustering rounds?
This is due to how the the clustering algorithm that we used kind of works. So you kind of set thresholds for how far out from a point you could take in other points. Stationary objects have all the points very close to each other, so you can have a very low threshold and then get a very good cluster, even with multiple stationary objects close to each other. But we, of course, we had if we had more time, then we would have probably tweaked this a bit. But for the moving object, it was definitely harder. So we only cluster on objects that we are sure of, or we are very strict with what we make a cluster. If that answers the question.
I believe so. We have a nod. This was from the audience here in the studio. So very good. Thank you so much.
Yeah, thank you.
Great. And we'll move on to the next team. And last but not least, we have a Galaxial and Johan.
Thanks, Abba.
Hi.
So I'm going to share my presentation here. Just a second.
Yes, please.
All right. Hope you can see it as well.
Give you an okay. It looks great. So fire away.
All right. Thanks. Yeah. So we're Team Galaxial, consisting of me, Johan, and also Angelo and Mar. So we're 3 engineers from 3 different countries who have converged in Lund to form our team. So our backstory is that I helped supervise Angelo and Mar's master thesis, and that's sort of how we met up. Since then, we've actually been working all at the same company, which has been great fun. So we decided to take on this challenge, but not through our company, but rather as a fun project to do in our spare time, which absolutely turned out to be very challenging. So our initial impression of the problem was that this is hard. There was a lot of data available to us from different types of sensors with differing update frequencies, capture times, sequence lengths, and different coordinate systems. And this created a pretty large solution space. So as we knew from the start that we would probably be a lot more limited in time than some of the other teams, we quickly discarded a large portion of the solution space that involved what we would consider to be code and experiment intensive applications, such as tracking and sensor fusion. But we thought that perhaps we could automate to have some sort of sensor fusion still. So just as in the story where the evil witch feeds the children to make them better suited for consumption, we thought we'd prepare a nice and fat feature-heavy diet for our 3D detector to make it better suited for detection. So we were inspired in this approach by a paper written by Horizon Robotics in 2020, where they detailed an approach on how to paint the LiDAR point cloud with additional features that are derived from camera images. And on this approach, we went all in. We thought it would probably be one of our best bets to get a competitive score in the challenge, as it had potential to perform well, and the implementation wouldn't be too time intensive. So the components that went into the vision side of this system was a faster RCNN 2D object detector, and also a pre-trained mask RCNN instance segmentation algorithm. And LiDAR-wise, we formed a larger point cloud using 1 short-range LiDAR sweep along with 2 long-range LiDAR sweeps. And this formed a pretty big and dense point cloud. And to every point, we also added a time delta so that some motion compensation could potentially be inferred by the model. And all of these components really came together when the point cloud was projected into the camera frame and sort of imbued with the features from the vision algorithms. So for example, if a LiDAR point cloud intersecting with a pixel where the segmentation algorithm had found something interesting, that interesting information would also be added to the point's features and thus made available to the 3D detector. And the model we opted for to be sort of the basis for everything was the PV RCNN 3D object detector. And this was quite simply because it had very good baseline scores. So in the end, we ended up training this system for almost 2 days, I think. With, I think, 6 hours to the competition deadline, we decided to halt the training and try it out as we were running really short on time. And unfortunately, it didn't really produce the detections that were good enough. It might have been due to the choice of the PV-RCNN architecture or something else. We didn't have time to investigate that. So instead, in order to have something to hand in at submission deadline, we used our own 2D detections with the 3D detections provided by Sensac. We projected these into the camera frame and calculated the pairwise intersection of union for the 2D and 3D boxes. This formed a cost matrix which was used to associate the boxes through Hungarian assignment. And at this point, we were even shorter on time, so we didn't try to optimize the associations anymore at this point. So in conclusion, I think this was a great deal of fun while being really challenging. I think I speak for all of my team when I say that we learned a lot, especially regarding 3D detection and LiDAR usage. And the final moments of the competition could, of course, have been more glorious for us, but it was a gamble which we went all in on. And that aside, I think it was a great event with great support from AI Sweden and Sensac. And I agree with Simon in that it was a great competitors with really friendly spirit throughout. And I honestly don't know how many times I looked up this model that Roland from Annotationz provided, depicting the 3 different coordinate systems that were used in the challenge, which was extremely helpful. All right, and with that, are there questions?
Yes, thank you so much, John, and I think Johan, and I think you also mentioned something here that we tried to highlight also before. It's actually been a quite helpful group, this different teams, and everybody had the same issue with actually having a bit too little time. But that's something that, you know, this challenge is all about, that now after it, we have a lot of time to continue investigating these different solutions. So we have a question for you, Johan. Let's see here, how the association in the first model were going to work.
So we actually planned to use the same sort of associations. We just didn't, we didn't end up doing that too extensively. But there was always supposed to be some kind of 2D to 3D intersection of union assignments that we're looking at.
All right, thank you so much. I'll have a quick look, but I think that was the last question. So we say thank you so much. And I guess now we can't wait, right, to hear who is the winner from all of these really, really great teams. So thank you so much for the presentations. And here to eventually announce the winner is the CEO of Sensac, Örjan Andersson. Welcome.
Hi, thank you.
Great.
Thanks for having me.
Yeah, thank you for being here. Wonderful. Also kind of nice that we can have a little bit of a hybrid event finally. So that's
finally,
nice.
We can get to meet people in person.
And so we've run this challenge for some time, and you as the CEO of Sensac, why Sensac doing a challenge like this?
Yeah, I mean, if you start on a more overall level, we have like one of the hairiest problems in the world to solve, definitely the most difficult one in our industry, and that's creating autonomous cars. And we kind of believe a lot in reaching out, collaborating, and I think this is one way. We try quite many ways, and being here at AI Sweden, this is one of the places where we try to collaborate as well. But really what we want to do is to find inspiring ideas from outside of our walls.
And I think this is it's a really good way of doing it, right? Finding, using the network that we have together.
And I've been so excited to see some of the results here. I'm personally really glad that we have quite objective criteria to select, because if I was having to pitch in, I would like to select very many winners. So thanks to all of you who have been a part of this. I think it's been really exciting. I think one important part is, I think from our side in the industry also, to open up some of our data sets and so on to enable the collaboration, because it's quite easy to say we want to collaborate, but we also need to create some of the foundations for it.
And I think also what you mentioned here with opening up kind of outside your own walls and getting some inspiration from the community is what we can see here, right, in the challenge, having these teams. And was there something specifically surprising for you when you now saw the solutions?
Well, I think one of the things when we were talking through what came out of the teams, I think, and maybe you can guess this ahead of time, but it's anyhow very nice to see how people approach the problem from really different directions. And I know some of you felt there was a little bit shortage of time and so on, but still I think we got really inspired by the different approaches, and the end of development doesn't happen today. So if you want to keep talking to us and continue, we're really excited about it. But the difference in approach, I think there's actually really good things in the different approaches that we may want to learn more about, and maybe the best solution is really a combination.
That's great. So I think we kind of reached the goal with doing this challenge.
Yes.
Having actually kind of a buffet of solutions that might solve the issue.
Yes.
So
let's hope.
Let's hope so. That's wonderful. So we won't keep you waiting anymore. Who is the winner? And we are prepping a drum roll. And Lucas, can you share our slide? And drum roll is walking in. There, we got it. Thank you so much.
That is hands off the best drum roll I've seen in a very long time. Thank you.
Slide away.
Who would have thought this morning we would see an office chair become a drum roll? So, not to keep you in excitement anymore, the winner is... Do you want to hold my mic for a minute?
I want to hold it.
And the winner is Annotationz.
And I'll give it to you.
Yes.
And by chance, actually, some of the team members are here. We had some teams that could come in person. So we would actually like these two team members to come here. And of course, Roland, and I'm not sure if any of your other teammates are online, but I'm sure they are looking in. Welcome, guys. Come out. And give them another applause. Come in and stand here next to Adyad and receive the prize. So we'll take some photos, and we also have...
And we have a nice
piece of glass here for you as well.
Let me hold that so we get everything in the picture.
And yep. And we actually have there must be gold and glitter for the winners, right? So a few questions. I'll help you guys with the mic. That's the punishment of being here in person. So how do you feel?
Very emotional, I guess. Yeah, I don't know what to say. I just want to thank my teammates first. So Roland, Luca, and Jonathan that participate with me in that competition. And I also want to thank AI Sweden and Sensac for organizing this competition. And yeah, so that's what I wanted to say. Thanks.
Thank you. What was the most challenging thing about the challenge?
I think it's the time limit was the most challenging thing, and it was really forcing us to choose a tactic that we would be able to finish in time. And as all people working in programming and maybe engineering in general know, it's really, really hard to estimate what you are able to achieve within 2 weeks. So I think that was really key, not to aim too high.
Great. And I think maybe Roland, do you want to add something? You as the team leader of Team Annotationz?
Yeah, I don't know. I think the only thing is that we really enjoyed participating. We had a lot of fun. I am really missing calling my team members at 12 o'clock at night to discuss any new problems to run on the GPU overnight. So yeah, I'm looking forward to the next challenge.
That sounds great, and maybe now you can call them in eternity, or because now this continues for as long as you want.
Yes.
So thank you so much, team. They are winning 50,000 Swedish kronas from Sensac, and of course this nice plaquette. So thank you so much. Great to have you here, and we will be, I guess you will be also celebrating a little bit later. So thank you so much, and congratulations. And I'll keep Ödjad here, and this is also your prize. So you.
Yes. Thank you. Congratulations.
Okay, you're free to go in. One more applaud. Thank you so much. And I'll ask Mina and Benny to come back up on stage again. And I realized this confetti glitter is not really collaborating when you have it on your touchpad. So don't try that at home. So, okay, welcome back. So this was really fun. Now we have, oh, this is, they can also, this was the glitter. So. All right, here we are. Super fun, we have the winner. What happens next now? We've heard a few hints about data sets being available, etc. Ödjad, what do you see? What do you hope to come out of this now that the data set is actually out there?
Yeah, obviously, I would like to see even more great ideas, and please don't hesitate to reach out. I think actually Benny and Mina, who have spent much more effort on making this a reality, thanks to both of you as well. And I think you know more about how can people actually reach out if they want to as well, right?
Yeah, enough emerging technology.
Yeah, I mean, for me, this is only the beginning. And as we see now that this is a success, at least the plan that I foresee is, and plan for is for us to expand the data set and to enable us to create more challenges, start new collaborations and so on. So yeah, this is just the beginning. And as been mentioned before, for this challenge, if you have great ideas or if you want to continue the work that has been done, we are very open to seeing those results and discussing it with you. So
I think that's really great, because it's not only the teams that would be interesting to continue collaborating with, but also others out there with some interesting solutions who want to try to find solutions for this, right? And Mina, you mentioned before, okay, where can they find this data set?
Yeah, it's on Sensac GitHub account. So there you can just send us an email, and then we will share the link with you. And then you can download the data set, but also the challenge data, and then just start working on that. And let us know your feedback. Then we can improve on that. When we extend the data set, then we know what to add and so on. So you benefit best from it, while we also benefit from your ideas and innovations. Yeah.
And Ödjad, from your perspective then, being the CEO of company, so why would you encourage, or would you encourage others to take on this? It takes a lot of time and resources to create something like this, a data set and then the challenge.
Yeah, I mean, it does take some time and a little bit of effort. And as I shared, it wasn't really on my side, so I'm really happy that we spent. It also creates a lot of energy, I think, in the team on our side. So I think we get a lot back. But I really believe we will be much stronger together. So, I mean, I think anybody should try this. We're super excited. I'm sure we will do it again. We feel like it was a big success. But we would be happy to participate in somebody else's challenge as well. So.
Yeah. No, that's a great way of putting it. And also from AI Sweden's side, we would also love to see work being done on this data set. And what we can offer in addition is that we have this infrastructure that we can make available to partners or potentially other projects. And I mean, the end goal here is also to see if we can use the Edge Learning Lab that is created here by a few partners together. For example, Sensac and Volvo Cars and CGIT, HP and Ericsson. So how we can actually take this all the way out to the edge and try to see if we can make that solution. So that would be wonderful to see how we can collaborate on that going forward. And I see Benny wants to say something.
We have plans for the Edge Lab.
So with that, I want to say, just checking, so there's, check the chat here because you can find the links. We will also, of course, make them available through AS Sweden, so you can find them easily. You can also check out, of course, on Sensac's websites and contact them to get a hold of the data set and the challenge description. But I want to say thank you for everyone who was participating and making this challenge happen. It's been really great fun, and we actually just look forward to continue the work from here. Like Benny put it, this is just a start. So please don't hesitate to reach out. Thanks so much to everyone. Thank you for listening in. Thank you for all the speakers that we have today. And also, most of all, thank you, teams. Yes. It was wonderful working with you. So an applaud and thank you.